4, solving logarithmic and exponential equations. So here we're looking at mainly using the log laws to solve equations. So let's have a quick recap of that. Well, the kind of key definition for logarithms is that y equals a to the x is the same as saying that log to the base a of y equals x. I.e., if I take the logarithm of a number, it's the power to which I raise the base by to give that number. The most famous logarithm functions and exponential functions are probably y equals e to the x and y equals natural log of x. You'll see the red curve is y equals e to the x, the exponential function. And if I reflect that in the line y equals x, I find the curve of its inverse function, y equals the natural log of x. So during the course of these examples, we're going to use these three laws fairly extensively. And we've got the multiplication law at the top, the division law, and the power law for logarithms. So let's make a start. Question 1, we're solving 3 log to the base a of x equals log to the base a of 27. And we're going to use the power law first of all to write the left hand side as log to the base a of x cubed is log to the base a of 27. And now we've got them all just log to the base a of something on the one side equals log to the base a of something on the other side. And so we can take exponentials to the base a. So we get a to the power log to the base a of x cubed is equal to a to the power log of base a of 27. So x cubed is equal to 27. So x is equal to 3. Okay, moving on to 2. So you want to use the power laws, and we're going to start with the left-hand side, and we're going to aim to get it to the right-hand side. So it's to show that question. So the left-hand side is 2 log to the base 10 of 5 plus log to the base 10 of 4 minus 1. Well, I'm going to use my power law first to write this as log to the base 10 of 5 squared plus log to the base 10 of 4, and then the 1 I'm going to write as log to the base 10 of 10, because 10 to the power 1 equals 10. So we get log to the base 10 of 25 times 4 minus log to the base 10 of 10. Well, that's log to the base 10 using the division law. 25 times 4 is 100, so 100 divided by 10 by the division law, which is log to the base 10 of 10, which is 1 as required. Question 3. We're starting with this nice identity here that we're going to try and solve and find the values of x that make this true. So we're going to start with combining our logarithms. So we're going to say that log to the base 2, and this becomes x plus 3 squared using the power law, and then applying the division law divided by 2x. And I'm going to write 3 as log to the base 2 of something. Well, it's log to the base 2 of 8. So I can now exponentiate or take exponentials to the power 2 of x sideways thing. And we end up with x plus 3 squared over 2x is equal to 8. So expanding those brackets, we've got x squared plus 6x plus 9 is equal to 8 times the 2x, which is 16x. We get x squared minus 10x plus 9 equals 0, and we're going to factorise this to get x minus 1, x minus 9 equals 0. So therefore, solutions to our original equation are x equals 1 and x equals 9. Final example for this sheet is this one that looks a little menacing, but let's give it a go. So we're going to start by saying we are told to use the substitution y equals 2 to the 3x. Well, quite often these boil down to disguised quadratics. So if I start with y equals 2 to the 3x, what do you think y squared looks like? Well, y squared is going to be 2 to the 3x all squared, but that's the same as 2 to the 6x, which again we can write as 2 to the power 6 all to the x, which is 64 to the x. So it's looking like we're probably on the right track. I can now start thinking about what this 2 to the 3x plus 2 looks like. Well, bearing in mind I want to get it in terms of y, that's the same as 2 to the 3x times 2 squared, which is equal to 4y. 2 squared is 4. So that now means that 64 to the x minus 2 to the power 3x plus 2 minus 5 equals 0 is the same as writing y squared minus 4y minus 5 equals 0 if y is equal to 2 to the 3x. So hence we end up with y minus 5 and y plus 1 equals 0. So that tells us then that y equals 5 or y equals minus 1. But we know because as y is 2 to the 3x, y equals minus 1 gives no solutions. Hence, we have our solution being y equals 5, i.e. 2 to the 3x equals 5. So if I take logarithms to the base 2 of everything, then we end up with 3x log 2 of 2 is equal to log 2 of 5. So x equals 1/3 log to the base 2 of 5. And that's the end of our examples. So please try the exercises on the sheet and then the exam questions that go alongside as well.